Hi, so this is part 2 of looking at what is a surd and continues on from my previous video. So I've written again the integers 1 to 9 with the square root sign around them, and let's just do a quick recap. So the square root of 1 is 1 because 1 times 1 is 1. Okay, and then the next time we come across a root that's going to give us an integer is the square root of 4. The square root of 4 is 2, because 2 times 2 is 4. And then we have to go along to root 9 to find our next integer, and the square root of 9 is 3. In the last video, I was explaining how any of these roots that are in between cannot give us an integer as an answer, because root 2 and root 3 will have to fall somewhere between 1 and 2, and root 5, root 6, root 7 and root 8 will have to come somewhere between 2 and 3. Let's have a look. I've got the calculator out this time, so let's see what happens if we put in the square root of 2 and press the equal sign. What it's going to do is just give us square root of 2, because that is the most precise way to write that value, root 2. There isn't a more precise way to write it than that. If we want to show it as a decimal, we have to use this button here, which is the surd to decimal button. And if I press on that, we are going to get 1.414213562. So it's going to give us that value to 9 decimal places. But that's not where that ends. It's just where it ends on the calculator. Let's have a look. If I go onto the internet and have a look at, this is a site on NASA, just Google square root of 2, it will give us the square root of 2 to 1,000,000 places. So you can see that's quite a tricky amount to work with, isn't it? So of course, we don't want to have to do that. And we don't need that level of accuracy. But it goes to show us that the most specific way of writing that number, the most precise, is to just write it as a root 2. So that's what we do. And that is a surd. And what I've also done, just to help, is to Google. Always feel like you can Google things if you want an explanation. Let's see what it says here. So Googled what is a surd, and it gives us this definition. A surd is an expression that includes a square root, cube root, or other root symbol. Surds are used to write irrational numbers precisely, because the decimals of irrational numbers do not terminate or recur. They cannot be written exactly in decimal form. And looking at that NASA site, we can see that that makes a bit of sense. So although that seems quite a lot to take in, think of it that way. We can show it on our calculator and it will show us to a certain number of decimal places. But actually, to get an accurate figure for that, it will just go on forever. Okay, so hopefully that's giving you some insight into what a surd is and why we just choose to write them in this form. But there's one other word we should just mention. If you go on to do A-level, you'll learn a lot more about irrational numbers. But if we've got a definition that includes something else that is unexplained, we ought to have a quick look at that. So let's just have a look what it says about irrational numbers. Again, I've Googled it and we get an irrational number is a number that cannot be expressed as a fraction for any integers. So if we go back to that 1,000,000 decimal place result, perhaps it will give you some insight as to how that would, just not be possible to write as a fraction. And let's just have a look at something else. Let's go back to my board. If we think about 0.3 recurring, I'm going to wipe this and let's talk through it again. If you think about a recurring decimal, which we do get, so we have 0.333333, and if you've ever tried to divide by 3, if you had 10 divided by 3, if you're doing it manually, you learn pretty quickly that you're going to get 3.33, and you're going to keep having the same remainder, so you're going to keep having the same decimal, and it becomes apparent that that is not going to change, it's recurring. So 1 divided by 3 would give us 0.33333, and of course we can simplify that to 0.3 dot above to show it's recurring. But again, the way that we may choose to write it, which is precise, is 1/3. So we can take that and we can write it as a fraction. If you've got numbers such as surds, which are irrational, you can't do that. I'm going to show you one little trick before we end. And if you're doing GCSE, you'll learn this if you're doing GCSE higher. How we could prove that 0.3 recurring is equal to 1/3. What we're going to do is we're going to use algebra to prove this. And we can say, let's make x equal 0.3. Then we could make 10x, or rather not we can make, 10x would equal 3.3 recurring. We're just moving it up the place values, so we would get 3.3 recurring. And here's where it gets neat. So if we want to get rid of that recurring, what we could do is subtract x from 10x. So we're going to subtract 0.3 recurring. I'm going to get rid of that from there so it doesn't confuse. And then what we're going to end up with is 10x minus x is 9x. 3.3 recurring minus 0.3 recurring, well, they're going to cancel each other out. And so we're just left with 3 minus 0, which is 3. We're going to divide both sides by 9, which will give us x equals 3/9. And that, of course, can be simplified to 1/3. So there we've proved that 0.3, which is a recurring decimal, can be written as a fraction. Now, that is just moved out of what we're talking about, surds, into something different. But as you do maths, you will find the more you do something, it leads you on to something else. Everything is very connected. But let's just go back and recap on surds. So if we have a root sign, and I've just used square roots, it could be cubed roots or any other root, then unless you have got a square number, then you are going to find that you have a surd, because any of these, if we try to put them into the calculator, so let's take root 7, so we can go root 7, and if we press equals, then it is just going to give it to us in that form, root 7. If we want it in decimal, we have to ask it to change it to decimal using this button here, and then it will give it to us for the first 9 decimal places. Okay, I hesitated here because I was going to look at root 8, but I think perhaps that's for the next video, because if I put in root 8, what we're going to get is 2 root 2. So I will leave you with that, and we will return to that at a later video. Okay, thanks for watching.